All right, in this video, we're going to do a couple different things. We're going to review our phase changes, kinetic energy versus thermal energy, and physical and chemical changes information that you may have missed either on Monday, March 1st or Thursday, March 4th. And then we're also going to talk about how to complete checkpoint 4. So, starting with kinetic energy, we have talked about kinetic energy quite a bit, and we've talked about it when we talked about states of matter, and we talked about how solids have the least amount of kinetic energy. A liquid has more than a solid, but less than a gas, and then a gas has the most kinetic energy. But what does that mean? So when we talk about kinetic energy, we're talking about energy that an object has because of its motion. Those particles of matter are constantly in motion, which is that kinetic energy. And again, that kinetic energy all depends on what the state of matter is. When we talk about kinetic energy, we also have to talk about thermal energy. So this is energy due to the motion of the atoms. Thermal energy is going to cause temperature to change or the phase to change. So from a solid to a liquid or a liquid to a solid, all that stuff. And when we feel heat when thermal energy is transferred. So when we talk about phase changes, we have to talk about kinetic energy and thermal energy and the change that it's going through. So we know that with gas, those molecules are constantly in motion. There's lots of kinetic energy. And with that being said, that means there's rapid movement of particles. So there is a higher amount of thermal energy. And what I like to think about when I think about gas having a high amount of thermal energy is like if your parents are steaming or ironing clothes, that steam that comes out of it is very, very hot. So if we were to take a gas and turn it into a liquid, that would be the phase change called condensing or condensation. And if we were to take a liquid and turn it into a gas, that would be evaporating or evaporation. So here are two examples for those phase changes. Evaporation, if we put a boiling pot of water on the stove, we have the water vapor coming off of it. And then if we were to fill up a glass of water or lemonade or something and set it outside, water droplets are going to form on the outside of that cold glass, which is condensation. For liquids, we know that the particle motion is more than that, or less than the gas, but more than a solid. And those particles are moving and gliding and flowing over top of one another. So there is some movement of particles. So there is some thermal energy. With a solid, we know that those molecules, they don't move very much. They vibrate and they're in a very defined shape. Okay, so with that being said, there is a slower movement of particles and less thermal energy. And this phase change is probably the one that you're most familiar with. So liquid to a solid, freezing, solid to a liquid would be melting. So here are those here are the 4 words that we just talked about, but we also need to talk about sublimation and deposition. So if we were to take a solid and go directly to a gas, that would be sublimation. And deposition would be a gas going directly to a solid. So what I want you to do, we'll talk about that at the end. So when we talk about phase change, we also have to talk about physical change. So with physical changes, that's just a change in the way something looks. Peanuts grinding down to peanut butter, copper turned into copper wire, paper being folded into a paper airplane, or ice being melted into water. When we see a chemical change, that is a change in the identity or the chemical makeup of the substance. But all chemical changes cause a physical change as well. What makes it a chemical change? The change in the identity. If I fold up paper, it's still paper. It's not anything different or new. It's just paper still. But if I were to take logs and burn them, that is a chemical change because it's burning. There's an odor coming off of it. There's a change in color. It is a new substance. It's ash. It's soot, okay? If we took an iron nail and it oxidized and it rusted, that would be a chemical change. Yes, we see the physical change happen as well. It looks different, but at its core, it is a chemical change because it is a new substance. Now, for checkpoint 4, my suggestion before you do checkpoint 4 is take these words, write them down in a notebook. Once you have written them down in your notebook, I want you to define the words. Okay, what is the definition? And to help you, what I would do is I would write chemistry, and when I'm typing in Google, chemistry after each word. Evaporation, chemistry. Condensation, chemistry. Melting, chemistry. Freezing, chemistry. Sublimation, chemistry. Deposition, chemistry. Because some of these words have a couple different meanings. So I would make sure to put chemistry after each one to get the chemistry definition. So once you do that, you're going to hop over to Summit, and we are in the Matter project. And you're going to want to do the phase change checkpoint. And it just says label the arrows on the slide 2 with the name of the phase change. You can use sublimation, the words on the slide that I had right here, or you can use these. They mean the same thing. So you're going to be labeling this chart. What is it when a solid turns into a liquid to a solid, a liquid to a gas to a liquid, a solid to a gas to a solid. You're going to label those and tell me what that means, and then request for feedback. And that is checkpoint 4. If you have any questions, please ask your science teacher. But we are moving forward after this checkpoint. So on Monday, the 8th, we are moving on with new content. So if you did not finish this on your A or B day, you need to make sure you do that.